Here's how to explain why a discus will have a lift force acting on it based on the Bernoulli principle for A-level PE. So firstly, you'd want to acknowledge that the discus itself has been released at an optimal angle of attack. And that optimal angle of attack will be roughly below 45 degrees. So just below 45 degrees. You then say that that optimal angle of attack has helped to create an aerofoil shape. And an aerofoil shape is one that looks a bit like this, where there's airflow that's more curved over one side of the object compared to the other. And then with this airflow, you would say how the airflow going over the top of the discus has to travel a greater distance, and therefore it has to travel at a faster velocity to cover that distance. And when air travels at a faster velocity, the air particles become a lot more spread out. Whereas the air travelling underneath the discus travels less distance, so it travels at a slower velocity, but that means that the air particles are a lot closer together. And when the air particles are closer together, that creates a higher pressure. Whereas when the air particles are further apart, that creates a lower pressure. So you end up with this pressure gradient with high pressure airflow underneath the discus and low pressure airflow above. And that creates a lift force with the high pressure pushing the discus upwards and keeping it in the air for longer.